course I didn't know.
No?
Nobody knows. You never know that, yes.
Yeah.
It was a complete surprise, yes. Very, of course, very happy to receive it,
Yes.
but unexpected, yes. I think undeserved, I think.
You're very humble. Well, having looked at your fantastic work you've been doing, I think the description for the Shaw Prize said that your work solved old problems and revealed beautiful connections between areas of maths, which I think is a very nice summary of all of the things that you've been able to work on. And I also saw in researching your career that you spent some time in Oxford.
Yes.
Yes, so could you tell us a little bit about how you came to Oxford, what do you remember from being in Oxford, and sort of where it led you?
Oh, yeah. That played a very big role for me. So how I came, so when I was a student in Bucharest, undergraduate, I had a course, a professor gave a course on Atiyah-Singer in the index theorem. So I studied that. I was interested, and then I went to some summer school in Italy just after finishing undergraduate school, and I met Singer. He was at summer school, and I showed him some paper which I wrote, which has something to do with Atiyah-Singer theorem. And and I said that I was invited to go to Warwick for something which I was not that too much interested in, dynamical system, some symposium, something. But I told Singer that I'm going to Warwick, and he said, "Oh, why don't you come?" He was just going to Oxford. I said, "Why don't you, when you go to Warwick, you should also come to Oxford to meet Atiyah." So that's what happened. And then when I did that, they were just discussing some problem, I think, and they were telling me what they were discussing. And then I had an idea how to solve it, I think.
As you do.
Yes, and then Atiyah told me that, okay, maybe you should move from Warwick to Oxford. So then I moved. And I stayed 2 months in Oxford, and I solved this problem that he had, and then in the end, by the end of this time, he arranged that I will be invited to Princeton, because he was moving to Princeton.
Yes.
So I spent 2 months in Oxford, and then I moved to Princeton, and then I become some unofficially his student, Atiyah student. Yes.
And then, as you say, you then went over to Princeton, and then you've kind of stayed in the US since?
No.
You came out to Warwick, wasn't
I came to Warwick, yes. So I stayed 2 years in Princeton, and the second year I also became a student, a graduate student. So and I got a PhD in this second year.
That's very quick to get a PhD.
No, but I wrote something before. So after the first year, I wrote something, a paper, and I went to professor at university, asked him, can I get a PhD for this paper? And said yes, and then you have to register for 1 year. So it had it, so that's what happened. And at the end of this time, I got, so Atiyah knew some people at Warwick, and he arranged, I got this, some position at Warwick, So I stayed there for 6 or 7 years.
And then moved to MIT,
yes.
Which is where you're still based?
Still based, yes.
Yeah, okay. Fantastic.
Yeah.
And so I was fortunate to meet Michael Atiyah, Sir Michael. I think I met him in 2018, or 2017 or 2018, just before he passed away. And he struck me as just a really nice person.
Oh yes, he was.
So if you have any sort of memories of working with him or just about him in general, I'd love to hear them.
Actually, for me it was like my family. I think he and his wife, they played a role, because I didn't. My parents were my father was already gone, And my mother was in Romania. I couldn't see her anymore, so so they invited me to meals and all these things.
Yeah.
Really wonderful, yes.
Yes, that does sound like.
Not only that, I think at some point I had a fever, and he drove me to the doctor. I think he gave me he drove back. Yeah, so yes.
Yeah.
I don't remember doing that to any of my students.
Yeah, it's different times.
Yes.
Different times. The first one is: do you prefer whiteboards or blackboards?
Blackboard.
Okay. Yes. Correct answer. I agree with that. Okay. Pi or tau?
Pi or tau? I don't understand. What's the difference? What
So pi is obviously pi, and tau is 2 pi. And
tau! I didn't know that tau is 2 pi.
Yes.
I never heard of that before.
Okay, so pi would be.
Yes.
Okay.
I didn't know tau is 2 pi.
I only recently discovered this, but there is a very vocal group of people that think we should define everything based on 2 pi or tau rather than pi.
No, I didn't know that. Yes, pi.
Which I can understand, because it's, the full circle would be 2 pi.
Oh.
Going back then a little bit to our conversation about sort of your work in abstract algebra in general. So this is, as I mentioned, a subject that I have to teach to my first years, sort of their first course in group theory. And they find it very difficult. Not everybody, but a lot of the students, because of the abstract nature of abstract algebra. And I was wondering, and they asked if I could ask you this question, if you have any advice for students who, in terms of studying abstract algebra or anything, I don't know whether you have any particular techniques or particular suggestions for students that find the abstract nature of the subject difficult.
No, but I'm the wrong person to ask because I was a topologist.
Okay.
I started as a topologist. I was not an algebra. I was a topologist, and it just happened that I could use some things I learned in topology to solve some problems in algebra. But if I had to do pure algebra, I don't think I would have gone anywhere. I think that's my impression.
Okay, and then what drew you to topology? Was it the kind of the visual aspect of the subject, or I guess what drew you then as a young mathematician to want to work in topology in the first place?
Maybe there was one professor in Bucharest who was very inspiring, and so I liked what he was. So I sort of followed his courses. I think he was the one who gave this course on Atiyah-Singer theorem.
Right.
And in fact, he also gave a course on. He had 2 courses. The other one was on representation theory. Some Gelfand, something of Gelfand-Naimark work in induced representation, which I didn't understand. I didn't remember. I forgot completely. But Atiyah-Singer, that I absorbed. So I think because of him, I think I went in that direction.
It sounds like that had a big influence on the sort of subject you worked on.
And it was, I think, this topology is very. I think it's a very good preparation for doing algebra. I think.
Yeah.
In fact, I once talked to Serre. He told me same thing happened to him. I think. Serre was also topologist as a young person, and then gradually moved to algebra and using his experience in topology. So that's.
So maybe the advice for students that struggle with abstract algebra is to do topology first.
Yes, I think so. Yes,
okay, brilliant. Degrees or radians?
Radiant? What is a radiant?
In terms of measuring an angle, do you use degrees? Would you prefer degrees or radians?
Degrees.
Degrees? Okay. Yes. Do you have a favorite number?
1, I think.
Okay, why 1, if I may follow up?
Because that's a generator of integers.
That's fantastic. It's a very group theorist answer. I like it. Okay. Something else I came across in your online biography, it mentioned that you practiced yoga.
Yes.
Do you still practice yoga?
Yes.
Oh, okay. And it's sort
but
of
less than before, because I used to do headstand every day, and about 7 years ago I got injured very badly. So you cannot do it at my age. So so I got some. So that I had to eliminate. So So.
Just the simpler moves now, or you just have to stop completely?
No. I still do yoga, but
eliminate.
No, headstand is eliminated. Yes.
I think the quote that I read sort of said that you found it very relaxing and very different to mathematics.
Yeah, it's complementary. Yes.
Yes, complementary. Yes. So can you elaborate a little bit? What do you sort of mean when you say it's complementary to mathematics?
Well, it means that when you're doing yoga, you don't think of mathematics. I usually think of mathematics most of the time, but at that time I don't think of mathematics in that sense.
I see.
Yes.
So that was like the one thing that you found that allowed you to not think about maths.
Yes.
Give your brain a bit of a break.
Yes.
Okay. Interesting. Is there a particular mathematical fact or theorem that you just find particularly delightful or beautiful? Is there any sort of result that you really think captures the essence of mathematics for you?
Oh, I can remember I had this what's called qualifying exam, for Princeton.
Yes.
And I think Serge Lang, he was, Serge Lang? You know this name?
I do know the name, yes.
So his question was, what's your favorite term in algebra?
Okay. Me. Favorite term in algebra?
Term in algebra, yes. And I said, Hasse principle. It's something about quadratic form. If it has a zero over every periodic numbers, a real number, then also a zero over a rational number. I said that, and then he asked me, "And do you know the proof?" And I said, "No." And he said, "Neither do I." and that was the end of the exam. At least that part of the examination. Yes.
Yeah. That was the exam. Brilliant.
Yeah.
Okay, and then I guess the last one. What is the first mathematical problem that you remember working on? Now I don't know if this means you are free to interpret this as something you remember from school that you particularly enjoyed solving, or maybe it's the first thing you remember working on at a slightly more advanced level, but just in general. What's the sort of earliest memory of a real mathematical problem that you recall?
No, but so I mentioned this thing that this problem was Atiyah-Singer mentioned that was my first serious paper. But of course, I wrote some less serious papers. I don't know if I should include those. I had some less serious papers before, but nothing as good as that.
Okay. Well, what were the less serious ones on? I'm intrigued now. Were these the ones when you were an undergraduate? I saw that you published some things as
undergraduate, yes.
Yes.
Well, for example, I had some. One was something. There was some spectral sequence for vibration, which I found with another person. We found a much simpler proof.
Oh, okay. Yeah.
For something, so that the one in the literature. But I don't think it's comparable with other things. So that's.
I mean, I would argue anything that you have managed to publish properly, as you say, in the literature as an undergraduate, I think is incredibly impressive.
Yeah, but this was
only my students did that.
But this was accepted by. This was published in the mathematics journal. Yes.
Yeah,
but it was not a real new result. It was just a new proof of something. Yes.
That's brilliant. Well, George, thank you so much.
Okay, very good.
Yes,
actually, it was quite nice enjoying.
Good.
Yes.
That's what I was hoping.
Yes.
So obviously, George has enjoyed this. If you have all enjoyed this, then please do remember to subscribe, like, comment. You know the drill by now. And I will see you soon with some more maths fun. Take care.